So let us continue with our project. So in this next step, we will first load a sample audio file. So let us see how it is done. Loading a sample audio file. So what exactly we are doing? See, the audio waveforms, now they are in these audio files, they are stored in the form of waveforms. And the waveforms means .wav, what it contains? It contains the value of the amplitude at different points. So we have to understand, like for an audio means what is the sampling rate, what is the number of samples, and those kind of things. Let us say take a sample row. So metadata, that is the data frame dot iloc any value. Let us pick up the first 0. Sorry, I did not convert it to code. This has to be changed to Python. Yes, Python. Okay. Done. So what I have sample underscore row. So these are the information that I am having here. This is the slice file name. That is the name of the file name that I am having inside that. Okay. And the folder name, everything is there here. Now I have to create a audio file path, because see here I am having file name and folder number is there. For me, fold number is there and the file name is there, which is this slice file name. Okay, so I have to join them to make a file path. So let us see how we can do it. So audio underscore path. Now this will be means I have to join 3 things for that. So let us see how we can do it. First I have to reach to that file location, that is till the fold. I will come here and I will copy the path. So I have reached till the fold. Then I have to, just 1 minute, plus. Now I want to add this thing I want, for which fold it is there. So here I will use str sample row of fold. Plus I have to put, sorry, by mistake I pressed, okay, no issues. Plus I have to give double \, and plus sample row file name, slice file name. Intuitively you can understand what I have done. First I reached this point, fold. Then I selected the fold, means which fold it is, 5th, 6th, 7th, that I have selected. Means already fold was there in that. Okay. See here for data, fold is there, plus str. Here it should not be fold 1, it should be only fold. Okay. Plus str of fold, that number, it will return this number. Like this one was in this fold 5. So fold 5 is there, automatically this location becomes 5. Double slash sample row means what is the slice file name, that will come here. This is with the practice you will get it. It looks difficult, but it isn't really that difficult. Okay, so this is completed. Let me execute it. Okay, execution is also fine. Let me check whether it was created properly or not. Audio underscore path. See, so this is my audio path that has been created. Fold 5, and this is the file name. Later we will be making a function to make this path for all all these things. Okay. Now we have to load the audio from this file. Okay. So first I'll put audio, comma, sample rate. This is the syntax to load the audio. This will return us two things. Audio part will contain the value of the amplitude, and sample rate will give me the means how many samples were taken per second. So I have to do Librosa dot load. Simply I'll give the audio path. It is executing. It will take some time. It is done. So the audio and sample rate. We are having two parameters have been returned. Let us see what it is. Audio, if I simply open it, so many values are there. Dot 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 is there. So many values are there. Let me check the shape. So there are 7,002 entries. Okay. Let us see the type of it. So it is a NumPy ND array. Means one dimension array. Okay. And let us see what is my sample rate. Sample rate is 22050. So this means that in 1 seconds 2250 samples were taken. So if the size is 7002 and 22050 samples are there, then length of the audio upon it will give me how many seconds of audio is there. Say, here is my calculator. I have 7002 entries. And number of samples taken per second was 22050. So I have to divide it 22050. So it is 3.31755. This is my duration. Duration of the audio, length of the audio. Okay. Let us try to visualize this audio. So visualize the audio. Let us see how we can do that. plt.figure, fig size equals to 12,4. Now Librosa.display. We have already imported this library. Wave show. Here audio, comma, sample rate. This is all. Let us put the title plt.title. Audio waveform. Just a second. Okay. plt.x label. Time in seconds. And plt.y label. Amplitude. Finally, we will do plt.show. There certainly is a mistake. Eve form I have written. It has to be waveform. Okay. See, this waveform has been now plotted. 0.3 seconds. This waveform. This is the amplitude. So very interesting. This is how we have read the audio through the Librosa library. What we have to do next is that we have to extract the features out of it. Now, very interesting thing is here. We will be doing MFCC feature extraction. For now, we will not go into the detail of MFCC, means what is the full form of it. It stands for mel frequency Cepstral coefficients. So, that is quite complicated. Simply to understand, I will give you a very small example. For example, you consider that you have a photograph. So, if you take that photograph, so that photograph will be having a lot of pixels. Okay. See, for example, there is a photograph of a person. Now, if my machine learning algorithms and the ANN, it requires data in numerical format. This photo is also in the form of format, means there are pixels in it. So one option is that I can convert it into pixel values. That pixel values will be a very huge data, and it is like not a good thing to give to the ANN network. So what we are going to do, instead of directly converting it into pixels and feeding to the neural network, we are going to extract the features about it. For example, if it is an image of a person, say what will be his age, what will be his height, what will be his hair color. These kind of features that we will extract, and that we will give to the machine learning algorithm. That is ANN, or not machine learning, ANN neural network, or any even for the machine learning algorithm also. So that is a better way to do it, instead of directly giving the raw pixels. The same thing we are doing with the audio also. Just give me a minute. So same thing I will be doing with audio. In audio, what is happening, that the audio is given to me, it is in .wav format. So the waveform is coming like this, like this. It might be some any value it can be. So basically what I am getting these amplitude values in the audio. This has been stored in the audio. When we had loaded through Librosa, audio comma SR. There were two things, audio comma SR, right? So audio is the value, these values, amplitude values, it has been stored in form of array. Directly giving this value is not, because see, we are having different values will have different lengths, it will have large number of data. See, here only we are having 7,000 just in one, 7,000 entries in just in one audio file. We are having many audio files, right? About 1,000 audio files we are having. So it will become a bulky data. So what we are doing it, this MFCC are the coefficients. These MFCC coefficients, they describe, similar to what we have discussed in the pictures, it describes the type of audio. So generally 40 coefficients, means there are many coefficients. I mean, the number of coefficients can be decided by us, how many we can take. Generally we will take 40 coefficients because it captures in the best way. So now what is happening, for every audio file we are taking MFCC coefficients, and that we are feeding to the neural network. Now that is a better practice, because means here the data is more informative, and it will better help to train the neural network. So let us see how it is done. MFCCs equal to Librosa dot feature dot MFCC. This is the syntax for it. Y equals to audio. Audio is there, means we had read it no that time. SR equals to sample rate, and N underscore MFCC. This is the one that we can define. We will be defining it as 40, so that 40 coefficients will come. Let us execute it. Some error. Let me make this small. Okay, and now it is done. So let us see MFCC dot shape, MFCCs. You see there is 40 and 14. Now we have to understand what is this 14. 14 is the number of folds in which it was divided. Okay. For example, I have an audio. Say this is my audio file. So what the library has done, it has divided it into 14 equal folds. And for those 14 folds, I have coefficient 1, coefficient 2, coefficient 3 till coefficient 40. This is for fold 1. Then I will have for fold 2. Then I will have for fold 3. So that is why I am getting here shape as 40, 14. So what I will be doing, all these folds are there and all these coefficients. I will take the average of the coefficient among all the folds, mean of it. That way I will get a single vector. So one audio will be represented in with 40 coefficients. Let us see how we can do that. So MFCCs scaled equals to NP dot mean MFCCs dot T comma x is equals to 0. Okay, we have no, no error is there. Let us check the shape. Okay, so now it has come to 40. See, there is one more thing to understand, like when I was explaining that time, when you are making it into coefficients, means 40 comma 14 we had. Had it been some other audio, it would have split in some other different number of folds. So see, ANN generally requires a single, means fixed size input. Neural network, it requires fixed size input. And definitely all the audio that we are having in the data, it is not going to have fixed size, right? It may be of different lengths, 3 seconds, 2 seconds, 1 second. So that is why we do this. Okay, then let us move ahead. So I do hope that you understood this. We will now continue in the next video. In the next video, we will be making the function. That function will be doing the feature extraction work. Let us see how it will be done in the next video. Thank you.